Section 2.5, absolute value equations and inequalities. Absolute value means distance from zero. The absolute value of 5 equals 5. The absolute value of negative 5 equals 5. Distance is always positive. Solving means to find x, or x is plural, that make it true. Okay, so solve the absolute value of x equals 5. X could be 5 or negative 5 because we know that the absolute value of 5 and the absolute value of negative 5 are 5. So if we solve the absolute value of 2x plus 1 equals 7, we know what's inside must be 7 or negative 7, since we do inside first. And since the absolute value of 7 equals 7, and the absolute value of negative 7 equals 7. So what's inside there has to be 7 or negative 7. Okay, so we would set up our two problems and solve for x. And we get our two answers here. Solve the absolute value of 3x minus 4 equals 11. We're going to set it equal to 11, set it equal to negative 11. Okay, only do the number on the right. Only change the number on the right when you're doing the negative. Don't change what's inside. Okay, and solve. Okay, what if we have something like this where the absolute value is not by itself? We have to get it by itself. Okay, so we're going to take care of that minus 3 and add 3, and then divide that 10 divided by 2 to get the 5. Then we set it up equal to 5, and we set it equal to negative 5, and solve, subtract, and divide. Two answers. Okay, now two special conditions. The absolute value of x equals 0, that can only be x equals 0 because the absolute value of 0 is 0. Now what about the absolute value of a negative number? There's no solution there because absolute value is always positive. Okay, what about absolute value inequalities? Solving that means to find the set or sets of numbers that make it true. Okay, it's not just two numbers, it's a whole set of numbers. Okay, solve the absolute value of x is greater than or equal to 6. This means the distance, absolute value is distance, is greater than or equal to 6. And think about social distancing. In the United States, we used 6 feet. Okay, so social distancing would be like our example here, analogy. So the distance is more than 6. So we're talking about the distance from 0. So if the distance to be more than 6, we're talking about 6 and further right for the blue section, or we're talking about a distance of 6 to the left, which would be this red part, okay? So negative 6 is a distance of 6, but more means we would keep going further from 0. Okay, we're talking about how far it is from 0. It's going to be 6 or more. So that's why we're going to the left and the right, to be further away from 0. So we can see that blue section is x is greater than or equal to 6. The red section is x is less than or equal to negative 6. So how we solve is we split them into two parts, positive 6, negative 6. Okay, on the positive 6 side, all you do is drop the absolute value. On the negative 6 side, you drop the absolute value and flip the symbol. Okay, and our interval notation, we have our negative infinity to negative 6. We had or equal to, that's why we have a bracket. And then our right section would be from 6 to infinity. Remember, we read everything left to right in math. Left to right, everything. Okay, so solve the absolute value of 2x plus 1 is more than 3. So we're going to bring 1 down where we drop the absolute value. On the other one, okay, we keep what's inside exactly the same. For the -3, we flip the symbol. Okay, and I subtracted 1 and divided to solve. Okay, so x is bigger than 1 would be to the right. Less than -2 would be to the left. It doesn't have the or equal to, so we have parentheses. Our interval notation is -infinity to -2, union 1 to infinity. Okay, what about less than? X, the absolute value, is less than or equal to 3. The distance is 3 or less. Okay, so that means the distance from 0 is 3 or less. You can only go up to 3 in either direction. So from 0, we can go 3 right in blue, or from 0, we can go 3 left in the red. Okay, so we see that x is between -3 and 3. -3 is smaller than 0, 0 is smaller than 3. So for the less than, we do what's called nest. Nest it between the negative and the positive. Okay, brackets because of or equal to. So to solve the absolute value of 2x minus 1 is less than 5, we're going to put 2x minus 1 in between -5 and 5. Okay, -5 is smaller than 2x minus 1. 2x minus 1 is smaller than 5. Okay, we're going to always be using the less than on our nesting because we're going to put the negative on the left and the positive on the right, and it's between. So add 1, divide, and we get between -2 and 3, parentheses, because it doesn't have absolute value. Okay, graph. A negative absolute value is our v turned upside down. Opposite of inside tells us 1, and positive of outside, opposite sign inside tells us +1. Same side outside equals +3. That's our vertex. Okay, a slope of -2 out front turns it upside down, and the 2 means a slope of 2. So we're going from the vertex, we go down 2 over 1 in both directions. To find the horizontal intercepts for f of x equals 3 absolute value of x plus 2 minus 5. Okay, think about a graph. The intercept is where it crosses. So the horizontal intercept is going to be when y equals 0. Remember that f of x equals y, so we're going to replace y with 0 and solve. So we're going to get that absolute value by itself first by adding 5 and dividing by 3. So we set our absolute value up to equal 5. We also set it up equal to 5 over 3, and also -5 over 3. Okay, what's inside the absolute value stays exactly the same. So we subtract 2 to get a common, subtract 2 to get x by itself, get a common denominator, and it gives our 2 answers. And that is the end.